Hello and welcome to section 9.2, special right triangles. Our essential question is, what is the relationship among the side lengths of 45, 45, 90-degree triangles, 30, 60, 90 triangles? What you're going to learn is how to find the side lengths in special right triangles and how to apply that to solve real-life problems involving these special right triangles. Alright, so what we have here is a 45, 45, 90 triangle theorem. So what this is basically whenever we have a triangle that has a 45-degree angle, another 45-degree angle, and a 90-degree angle, we can use this theorem to figure out the side lengths of each given triangle. So basically how this theorem works is we take the 45 degree here, okay, 45 degree, the side that is directly across from that 45-degree angle. Okay, we're going to go ahead and call W. Okay, so here we have W. All right. Okay. Also, we have another 45-degree angle that we are also going to call by the side that's directly across from it, which in this case is also W. Now this makes sense because here we have what is called an isosceles triangle. We have a triangle that contains two congruent sides, and we know that these two sides are congruent because they both have the same length of W. In addition, we have two angles that are congruent to each other, and that's the definition of an isosceles triangle. Okay, so when this happens, okay, we can also identify the side across from the 90-degree angle, and we're going to go ahead and label that as W times the square root of 2. Okay, so W square root of 2 is what we're going to call our 90-degree angle. Okay, so this is the 45, 45, 90 triangle theorem. Okay, and we're going to go ahead and apply that on this next screen here. So what we have here is a triangle that has an angle 45 and an angle of 90. Now the first thing we got to do is we got to figure out what this angle over here is. And because this is 90, this is 45, we can figure out that this one here is also 45 degrees because of the triangle angle sum theorem. Alright, so what we're going to do here, I'm going to use this table on the right to sort of figure out what this x value over here is. Alright, so what we did on the previous screen, okay, the angle across from the 45 degree, okay, which is here, we called that W, which is right over here, right above this first box that we get to fill in. Okay, but in this case we actually have a value, so we're going to go ahead and call that 8. And over here on the left, I'm going to create an equation where W, the letter here in the table, right under the first 45 is a W, and I'm gonna make that equal to 8 over here. So now I know that W is equal to 8 because of this table that we just filled in. Okay, we're gonna go ahead and take this other 45 degree right here, and we're going to draw a line across, and we're gonna figure out, okay, that this side over here, because it's across from the 45 degree, is also W. But what we figured out over here is that W is equal to 8. So yes, this side over here is also equal to 8. Okay, and we find that makes sense because we have an isosceles which needs two equal sides because we have a 45 and a 45 here. Alright, so that's not really what we're looking for, but we have that information, so that's going to be helpful for us to find the value of the hypotenuse. Okay, so the value of the hypotenuse is across from the 90. So if we look at our table over here, we're going to go ahead and label that as x. Okay, because we're going to try to look for x. We'll be changing that in a little bit later once we find out what x actually is. Okay, so now I'm set up an equation. So I'm going to do W times the square root of 2. which is what's right above this x value here, and I'm going to set that equal to x. Okay, so these two over here on this column on the table, under the 90, I'm going to put those two things equal to each other. Now what we have is w times the square root of 2 is equal to x. Okay, so I'm going to go ahead and now substitute the value that we found for w, which is 8. So 8 times the square root of 2 is equal to x. Okay, so now we know what x is equal to. X is actually equal to 8 times the square root of 2. So I'm going to go ahead and remove that x, and I'm going to replace that with an 8 square root of 2, which is equal to 11.31. So this side here, where the x is actually 11.31. Let's try another with a similar type cases. This is still the 45-45 triangle theorem. Okay, so we're going to start here by first identifying what kind of triangle this is. So we have a 90. We have two congruent sides. We have two identical x's. So that means that this angle here and this angle down here, okay, those have to be equal to each other in order for this to actually work. For this to be x and this to be x, those angles have to be congruent. Now, because we know that this is 90 degrees, by the triangle angle sum theorem, we know that this angle here is 45 degrees, and so is this one here, 45 degrees. Okay, so now we can go ahead and start filling out our table. Okay, so we start with the first 45, doesn't matter which one actually, but I'm going to go ahead and go left to right. I have 45 degrees here, so I'm going to go ahead and draw a line across to find out what that corresponding side is actually equal to. So here we have x. Okay, so I'm going to go ahead and fill that in here. Of course, that's not a number, so we're going to need all numbers on this bottom row, but we'll figure out what x is in just a short second. And then remember we said that across from 45 is also w. So the key is to find w. So then I'm going to go ahead and circle the other 45 on the second column. Okay, and I'm going to draw a line across from that angle to the opposite side, okay, which we have as x. So I'm going to go ahead and label this as x as well, and that makes sense because both sides across from the 45 degrees have to be equal to each other. So all of this and these first two columns are identical to each other, w and x, w and x. Okay, now it goes to figuring out, okay, the 90 degree. So across from the 90 degree, we have 5 square root of 2. I'm going to go ahead and fill that in over here. So 5 square root of 2. That is the actual length of the hypotenuse. The hypotenuse is 7.071 units long. So we're going to use that piece of information to figure out what our w is. So I'm going to go ahead and set an equation using what I filled out in the table over here. So I'm going to fill it out just how it is. So I have w times the square root of 2 is equal to, okay, what is that actually equal to? And I'm right here, I'm not going to write that 7.07, but I'm just going to keep that 5 radical 2. Okay, and this is going to be so that we can see that this is evident. If we have square root of 2, we have a square root of 2, and we have w and w, well, it's clear to us that w is equal to 5. But we're going to go ahead and solve it just so that we can show that this is actually equal to 5. So here we have a multiplication. So we undo that, or we do the inverse to isolate the w. So we're going to go ahead and divide both sides by the square root of 2. Okay. Square root of 2 over square root of 2 is going to give us 1. Square root of 2 over square root of 2. Basically going to cross out, and then that's going to leave us over with w is equal to 5. Okay, so if w is equal to 5, okay, and we know that w is equal to x, okay, if w is 5, we can assume, or actually confirm, that x is also equal to 5. So now I could come back here to where I had put an x, and I can replace that with a 5. Okay, so my side lengths of this triangle are 5, 5, and 7.071. Alright, our 30, 60, 90 triangle theorem is when the hypotenuse is twice as long as the short leg, and the longer leg is square root of 3 times as long as the short leg. So what we're going to do here is we're going to set this up just like we did with the 45, 45, 90. Okay, we're going to start with our 30 degree because that's the first box that we got to fill here. So the side that is directly across from our 30 degree, okay, we're going to go ahead and label as W. Okay, we're going to keep that same variable. So here we're going to fill this in with W. Alright. Then we're going to identify our 60 degree. That's our second box. Okay, so what is the side that's across from 60 degrees? Okay, if we draw a line directly across, okay, we're going to see that 60 degrees, we have W times the square root of 3. So W square root of 3. And then lastly, we have our 90 degree. Draw a line directly across, and we see that whatever side is across from the 90 degree is 2 times, and then there's a typo here. This should be a W, not an X. Okay, so W, so 2W. Okay, so 2 times the length of whatever W ends up being. Okay, so 2W is what we have. Okay, so this is the table that's going to be essential for solving for the side lengths of a 30, 60, 90 degree triangle. Okay, we're going to go ahead and check this out. How does this actually work here? Alright, so first we have our 30 degree, and whatever is across from 30 degree is going to be equal to W. Okay, so in this case we have 30 degrees. Across from the 30 degrees is X. Okay, so here we're going to go ahead and put X. And I'm going to go ahead and right up here, I'm going to create an equation using these two values. So W is equal to X. W is equal to X. Okay, we'll come back to that once we start solving and have all the values in. Now, we're going to go ahead and fill this box over here for 60 degrees. So 60 degrees, we're going to go ahead and circle that angle. And we're going to draw a line across from that angle. And that's going to meet at this side at the bottom, the long leg, which is 9. Okay, so I'm going to fill that in with a 9. Okay, and then I'm going to create an equation for this as well, using these two values under the 60 degrees. So I'm going to say that W square root of 3 is equal to 9. Alright. And then last but not least, we're going to set up our 90 degrees. So then draw a line across from the 90 degree, and we see that that side is equivalent to Y. Alright, and then lastly, we're going to set that equation up as well. So we're going to have 2W equals Y. Alright, so from all of these equations, W equals X for 30 degrees, W square root of 3 equals 9 for the 60, and 2W equals Y for the 90 degree side. We know we can only solve one of them, and that's going to be this one down here, because it's the only one that has just one variable. It has a W, so we want to do that rather than solve for any of these because they have two variables. Okay, so first what we're going to do here is we're going to isolate the W. Again, because this is multiplication, we're going to go ahead and divide that by the square root of 3. Square root of 3 cancels out with square root of 3. Okay, and then we're going to go ahead and leave it how it is. We're going to have the calculator give us our value. So then we have W is equal to the square root 9 over the square root of 3. Okay, so then that is going to give us, this is key, once we have W, we're able to find all the sides. Okay, because here we have a W, so I could change that. I can say that X is now equal to 9 over the square root of 3, because W was 9 over the square root of 3. Okay, so now I can change this X to become 9 over the square root of 3, okay, which is 5.196. Okay, so then X is equal to that, so then X, this side right here, is 5.196 units long. And now that we have W, we can easily find the value of Y as well. So if I substitute this 5.196 for W, I can solve for Y by multiplying it by 2. So then 2 times 5.196 is equal to 10.39 approximately. Okay, so then Y here is equal to 10.39. Okay, so we're going to erase the Y, replace that with 10.39. Okay, and there we have it. Those are my 3 sides. So we have 9 as a long leg, and clearly that is longer than the short leg, so it makes sense. Okay, these numbers make sense. And then our longest leg is, the hypotenuse is 10.39, which is longer than A and B, so we know that that is also a value that makes sense. Okay, now how do we actually apply this to something that occurs in real life? Okay, so here we have a truck. Okay, that truck is on a ramp. So what's going to happen is that this ramp is going to basically just like lift up. Okay, and it's going to create this triangle right here. Okay, so what if we had a ramp that's unloading this truck, and we want to find out how high the ramp goes. Okay, so what is the actual measurement of that height right there? If our tipping angle, this angle here, is 30, and what if it is 45? Okay, so we're going to go ahead and start first by figuring out what is the height when our tipping angle is 30 degrees. Alright, so let's label one more thing on here. We know that the ramp itself is 80 feet. Okay, so then we have, I don't know if we're going to be able to see this through the truck, but here, that side right there is 80 feet. Okay, so we know that side right there. So what we're going to do here is we're going to use that value to figure out what this height is over here. Okay, so first thing we're going to do is we're going to set up an equation for this side down here. Okay, that height is across from our 30 degrees. Okay, so because it's across from 30 degrees, we can say that the height, I'm going to call H, let's color that in orange, make it color code, H, okay, which is this height right here, is equal to our W. Okay, remember that if we go back here, 30 degrees, whatever's across from 30 degrees is equal to W, so we're going to set that equal to W. 2 variables doesn't really help us much, so what we're going to do is we're going to try to set up something else that gives us a value for W. So across from this 90-degree angle is that side of the ramp. Okay, so we know that that side is 80. Okay, so I'm going to do 80 is green equal to, okay, and that is equal to, because it's across from the 90-degree, okay, we set it equal to 2W. So 80 is equal to 2W. Okay, so now we can figure out what W is because this equation has only one variable. So what I'm going to do here is then divide by 2 to both sides to give us W equals 40. And if W equals 40, then the height of our ramp is also going to be 40 feet. Okay, so if the tipping angle is 30 degrees, then the height of our ramp is going to be 40 feet. Okay, I'm going to go ahead and X that out, because now we're going to go ahead and do the one for 45 degrees. Okay, let's say we angle this a little bit higher then. Okay, so that angle there is now 45 degrees. So now we're going to be using the 45, 45, 90 triangle theorem. Okay, so again, we're going to want to find the height of the ramp, which is across from that 45 degree. So we know, again, that W, let's say the height, is going to be equal to W. So our 45 degree also across is going to be equal to W. But this again doesn't help us because we have two variables. So we're going to go ahead and use this side again, which we know is 80. And we're going to go across. Okay, so it's still across from the 90 degrees. Okay, so we're going to have 80 equal to, now this one's not going to be equal to the same thing because this is a different theorem now. So we're going to use the value for for when we have a 45, 45, 90. So that would be W times the square root of 2. Okay, so then here we're going to go ahead and divide both sides by the square root of 2. Divide by the square root of 2 to be able to find what W is. Okay, so W is equal to 80 over the square root of 2. And because W is 80 over the square root of 2, I can replace that in here and verify that the height of the ramp, if the degree is 45, will be 80 over the square root of 2. So if we type over here, 80 divided by the square root of 2. Oh, and of course that's not going to give us the exact value, so let me go ahead and pull out my calculator here. And we have 80 divided by 56.57 approximately. So our height is approximately 56.57 feet if we round to the hundreds. So I'm going to go ahead and change this over here. And all I did was divide 80 by the square root of 2. So that would be 56.57. Alright. Okay, and that is the end of this section. When using our 45-45 triangle theorem, we find the length using that theorem, and as well as the 30-60-90 triangle theorem, which has different sets of values. Okay, so I hope you enjoyed this video and I hope it was helpful. If you have any questions, please make sure to leave me some comments in the tile section down below.